Welcome to the Indiana and Illinois Bi-State Climate Webinar Series. Dwayne Friend is my counterpart who is traveling today and will not be joining us, but I am the Indiana connection here for this series. If you have any issues, any questions at any point in time, don't hesitate to put those in the chat today, and I will follow up with you. I did want to mention that I do have the ability to unmute turned off. So if you do have any questions for our speaker, feel free to put those in the chat and we'll deal with those at the end of the session, or if they would be pertinent to the topic at hand, I can always interrupt Beth and deal with those consequences. So with that, we have Beth Hall, the Indiana State climatologist, with us today. She's going to present on exactly the topic you should be seeing on your screen right now. Let me know in the chat if you're not seeing it. And after she wraps up, we will have a couple of poll questions that I'll open while we're taking questions for Beth. And then if you are only here for the Certified Crop Advisor credits, I will share my screen at the very end with a QR code, and I'll leave the QR code up for a couple minutes so that you can get your credits. And with that, I believe all the logistics have been covered. I'll let Beth take it away. Thanks for joining us, Beth.
All right. Thanks, Hans. All right. So I was asked to give this presentation, and from my perspective, I was thinking, yeah, I don't know if a lot of folks know when they are looking at their apps on their phone, if they know where that data is actually coming from. How do we know what's happening in our environment? Are there places we can look either on a website or on a remote device, a mobile device, to monitor the weather or climate conditions? And then are there any sorts of tools out there that I might recommend for agricultural purposes that might help in planning or decision making? So that's essentially going to be the gist of my talk. It's going to be broken up in a couple different sections, but the first part will be focusing more on data. But before I get into that, I wanted to just take a slide or two to talk about this area of climate science called climate services. Even my mom, I think, has really no idea what I do. When people think about climate, or if I say, oh, I do climate science, they might think, oh, you must be in climate change, and then maybe that will stir a debate of some sort. Or they might think, oh, you just do a bunch of averaging of the weather, so is it a very statistical type of career? But there is a subset of climate science called climate services. And I grabbed two quotes here from different sources that try to define what climate services is. Just reading the first one, it's to really equip decision makers in climate sensitive sectors. The other one, scientifically based information and products that enhance users' knowledge. So essentially what I do and others in this field of climate services is we have access to a whole lot of observational data out there, model data, what really comes down to numbers, spreadsheets, and databases. And then what we do is we try and figure out, but what is the information that an end user might want? And how do we translate those numbers into that sort of information? And then how can that information then lead to decisions? So as Hans introduced me, I'm the Indiana State climatologist. Last month, I believe you heard from Trent Ford, who's the Illinois State climatologist. This really is the gist of what state climatologists do, is they are looking at data, they're looking at information and trying to translate that into usable information for people to make decisions off of. So while that's an interesting background on a career field, I guess one of the points I'm sharing this with you is this is why we're here. If there are certain climate or weather related issues that you're like, hey, I can actually be better. I can be more productive as a farmer if I knew X, Y, and Z that is related to data, reach out to your state climatologist or even regional climate center, et cetera, so that we can better provide that for you. That's really what we enjoy doing the most. In terms of climate data and services in the United States, There are really three main levels of this. Certainly at the federal level, there is the National Centers for Environmental Information. Their main headquarters are in Asheville, North Carolina. And when you think of data that's being collected at all the airports across the US, or maybe some of you are cooperative observers, that data and many, many more data is being sent there and stored. And then you've probably heard of the National Weather Service. They also take the data and they can translate that into perspectives. Certainly, it's a little separate from their weather forecasts, et cetera. At the regional level, there's regional climate centers. And for each of these groups, I'm going to go through what offerings they have in terms of resources for climate monitoring and decision support that might be useful for the agricultural sector. So the regional climate centers, they focus more on issues and themes in their area. And in the Midwest, agriculture is one of the two main themes. And then at the state level, as I mentioned previously, there's the state climate offices, but then there's something that's called Mesonets. And I will spend a couple of slides talking about what these are. Mesonets are essentially a clever way of saying it's a network of weather stations, but on a smaller spatial scale. So more of a statewide scale, or perhaps a multi-state scale, or maybe multi-county state scale. And so when we're thinking about agricultural monitoring, those mesonets are going to be very critical because they tend to monitor things like soil temperature and moisture that you just won't find from these other networks. So starting off with federal data. Again, I'm bringing this up because I think a lot, and I'm guilty of this too, I look at an app on my phone and it might say, this is the current condition outside. Well, how does it know? Where is it getting this data? Or if it's saying it's been 10 degrees above normal or it's 2 inches below normal, what is this based on? And so this is a map of federal data sites. It's a volunteer network. We usually ask historically farmers to have a station and do this report every morning. The blue dots on this map are locations that are still reporting data, and the gray dots are those that we have data for, but they're no longer actively reporting. So in a sense, this is it's a network of weather observations. Some go back to 1895, and from the box on the left, you can see that these are really just daily summary data, temperature, max and min, and then precipitation, whether it was rain, snowfall, and then snow depth in the wintertime. So you can see the density. Almost every county has a station or had a station in it. And so that's what provides us probably the most foundational information about climate and how it pertains to things such as even your plant hardiness zone map is going to be largely driven by this data in terms of how much rainfall do we typically see in a county or an area will come from this data set. Another data set that is also run at the federal level is from airports. And these are more automated stations. So the previous network are volunteers, people like you and me that get up every morning anyway and have agreed to go out and take the what was yesterday's, if you will, or the last 24 hours precipitation and temperature. These are automated stations, and you can see that there are far fewer gray dots on here. So most of these are active and have been active, and we usually give a start date of around 1948. Because they're automated, it's nice because that means we can get sub-daily data, or hourly, if you will, in some cases even sub-hourly, say 30 minutes or 3 times an hour. And on the box on the left, you can see other things that are nice from this data is humidity, winds, pressure, and cloud height. And so when we're thinking of agricultural practices and decision making, obviously humidity is going to play a big role. If we're thinking about disease or transpiration, evapotranspiration rates with the plants, winds could be important if we are doing chemical spraying on the fields. Pressure and cloud height probably are not going to play as big of a role as temperature, precip, humidity, and winds. However, you can also see with the map that the density of these stations, it's not one in every county. And so how do you interpolate if there's winds in one dot and winds in another dot? Can you actually assume that the winds right at your field location are going to be the same? And that has been an issue when we think about chemical applications and drift. The final network I wanted to just show is a relatively younger network. It's called the Climate Reference Networks. And I just kind of zoomed in on our bi-state area here to show you that there's only one station in Indiana. And from this, there's two in Illinois. There might be a third over on the western side. The important thing here is it is hourly, it is automated, much like those airport sites that I showed you before. But if you look at the variable list, something that's nice with those is they have humidity, but they don't have the winds, pressure, cloud height, but they do include things such as soil moisture, soil temperature, and then soil radiation is a new one. And that is a growing demand, if you will. As you know, plants need sunshine, and we are wanting more and more to learn about climate trends of solar radiation. We obviously know we have daytime and nighttime, so there's that. But are we seeing cloudier summers? Are we seeing sunnier harvest times? And what does those changes, say, in the climatology of solar radiation have to do with agricultural output and timing throughout the year? What's frustrating, though, is like in Indiana, if there's only one station and you know a single cloud passing overhead is going to be very localized, how useful is this? So we do have some solutions that I'll get to shortly. But before I get to that, if you're curious about, all right, well, that's interesting, all of that data exists, how could I ever download it to try and get the data for my personal area? If you go to the Midwestern Regional Climate Center's webpage, and I have the URL there up at the top, and at this point, if you were to go there, you should see a page much like what I'm showing. I put a circle around our online data portal, if you will, called Climate. It's sort of a twist on climate, if you will. And when you go into that site, you have the opportunity to access those 3 different data sets I was telling you about, in addition to a variety of other data sets. But what's also nice is in addition to the raw data that you can access from those locations, those weather stations, there's a bunch of other cool tools in climate that you can do, such as ranking by month. You can look at trends, such as how often do we have 3 days in a row with temperatures over, say, 95 degrees, which could be important if you're thinking about livestock health or even human health. You can find stations with the humidity data to see if there are trends in nighttime lows or humidity to see if it is more susceptible to disease growth in the plants. Now, in terms of services online, and that I'm talking about tools that you could access that might be useful if you want to understand more about climate in a certain area. For example, I've been approached in the state climate office of somebody, a grower, who might say, you know, I'm kind of curious about starting to grow peaches in my orchard, and I'm not sure if the peaches are going to do well. What I really need is some information, such as what are the risks of those nighttime lows at critical times of the year, how much precipitation do we get, etc. So that previous slide I showed through Climate, you can download a lot of that if you want to look at raw data and thinking about alternate crops. But the federal government, and up at the top in brown, it says NOAA's Climate at a Glance. And I didn't include a URL or a web address here, because honestly, I would just put in your browser search field, NOAA's Climate at a Glance, and you'll find it better. You can see a whole bunch of different tools here. I just did a screenshot of like the top of one of these pages. In that first row, you can see the different spatial domains. You can look at it from the global scale, national, regional. In this particular screenshot, I've highlighted divisional. Most states have 9 climate divisions. Certainly Indiana and Illinois do, but you can even get down to the county and city level, depending upon the product you're interested in. And then the next row down, you can see maps of the different climate information. You can look at time series in terms of, well, how have certain parameters changed over the years, rankings, and a variety of other information. So in this particular example, you can see in the fields, I want to look at the whole United States, but I want it broken up by climate divisions. I want to look at air temperature for February of 2022. You can see even that last field, I just wanted 1 month. I just wanted to look at February. But if I wanted to look at a 3-month period, say a season, December, January, February, I could have done that by simply changing the time scale from 1 month to 3 months. So depending upon your application, you can look at, well, how bad do winters get, for example? And this is an example of an output based on those parameters that I put in. So you can see that I'm looking at the entire US, but it is divided it up into polygons of climate divisions. And down at the bottom, it can give very summary information for the whole domain. And up at the top, you can see tabs where I can be looking at this in terms of what was the actual value for the average of that month. How did that rank? And you can see as a summary, it's down below, anomaly mean. And then with this website, you can actually click on a particular climate division and hone down even further. In this case, I think I might have clicked on just Indiana in general, and I could see for each of the 9 climate divisions, what was the value for February of 2022? How did it rank over a 128-year period? What was the anomaly and what was the general average if we look at a 30-year period? And I think the user can even decide, well, I want to look at a different 30-year period for comparison. This is a similar field, but you can see in the second line of rows now time series is highlighted. And so this is a time where maybe you don't want to look at a particular month, but you want to see over time. And that's important in terms of what is your risk assessment for a certain area. Do we have a lot of variability from one year to the next? So even though I can give you an average number, a single value, you might be more interested in knowing, well, that's the average, but how often does that occur? And am I at a higher risk because from year to year, it's all over the place? So again, there's a lot of pull down options you can pick for what you're interested in. In this case, the last field down at the bottom, I picked the Central Climate Division in Indiana. And then in the options, I can draw average lines, trend lines, etc. And then this is an example output of what it can provide. So in this case, for that Central Climate Division in Indiana, I was looking at average temperature for February. And again, I could have come up with a bunch of different months or even multiple month periods. And I can see that temperatures have been increasing, but I can also see in particular, even the last 10 years, even though there's an average value and where the trend is, it's been all over the place. And that difference is varied by 6-7 degrees from year to year. So it sometimes may not be safe just to rely on the climatological average, but to get a better feel of whether there's a lot of variability from year to year. In addition to these graphical outputs that I've shown, again, you can look at the data, and all of these, you can even download the data. You see up at the top left of the highlighted box, outline box, there's the download feature where you can download it as an Excel file, and I think different options if you want to play with the data a little bit more on your own. Climate at a Glance has so many other tools in there. I just love that website. I just list a few things here: monthly climate reports, billion-dollar weather disasters. The middle dot there, bullet point, national trends to see where things are going. So the streaks tool down at the very end, seeing how streaks such as days without precipitation or days over a certain temperature. So I encourage you to check that site out sometime to see what else is offered. Another tool that is offered at the federal level, this time the National Weather Service, is a product called Now Data. And I was able to find it online, but I do admit it was not easy to find. So at the very bottom of this slide, I said, these were the searches I did. I just did Now Data Indianapolis because I was going to the Indianapolis Weather Service office. And then once I got to that page, there was a link that said current and past weather. And that's how I got to this product. You can see on the left, there's a whole bunch of city locations there. So you may be able to find a location that's closest to you, and then a variety of products and then options that go along with those products. I'm just going to show a sample based on this one product that I have an arrow pointing to. That's the first and last dates, where if I would have selected that, then under the options, that number 3 column, I could have put in things of first and last dates of what. So maybe it was the first and last dates where the temperature hit 32 degrees or 28 degrees. And once I hit go, then it would provide me an output of, so what were the first and last dates based upon the parameters that I put in. So this might be an interesting thing for you to look at if you are curious about extremes, or is this the average last date? You can just look at the different options in here if you're trying to think of different freeze levels and printing or planting, and when to apply chemicals to fields and orchards and other agricultural activities. Now, data also provides graphing options depending upon what you selected. So this is an example of precipitation going back, it looks like maybe to the start of a year. And in this case, it's nice because it shows, well, what is the normal progression of accumulated precipitation over that time period? And again, you can select what your start date is and your end date is. You can see what the highest ever was. You can see what the lowest ever was and what the current year is doing. So a product like this might be useful if you're trying to think about irrigation solutions, or so what is the likelihood of precipitation coming through at a certain time of the year? And so think about these products, and again, trying to help you make decisions for your particular agricultural needs. Shifting over now to regional services. I mentioned that really the regional climate centers are the go-to source at the regional scale for climate information, and in particular for agricultural uses. There are 6 regional climate centers across the US, and this map shows the general coverage of those areas. And so both Illinois and Indiana are located within the Midwestern Regional Climate Center's spatial domain. We are located at Purdue University. So in addition to wearing the hat of Indiana State climatologist, I'm also the director of the MRCC here at Purdue. And while it looks like we just cover a 9-state region, really the idea with these regional climate centers is we try to develop products and information that are of most use to the residents in our region. However, we have access to data across the whole US. So a lot of times our products will hear demand from outside of our region that asks, hey, can you expand that tool, say, into the High Plains, or can you expand that tool into the Northeast region? So I don't want people to think, oh, well, maybe I have family that are in Nebraska, so they have to go to the High Plains. They typically don't have to, but yet the suite of tools, the decision support tools that one of the other RCCs have developed might be tailored more towards their regional themes. For the Midwestern Regional Climate Center, our 2 themes are agriculture and water resources. So we try to think about tools that will better serve those communities, those sectors. So I already showed you what our typical homepage looks like. Now I want to highlight just a few products from the other popular section of our webpage, which is called the Midwest Climate Watch. There are 3 main sections within the Midwest Climate Watch. You see those 3 tabs down below. So maps and images, I'll show you several examples of that. I'm going to skip highlights and reports for now, just because of time, and then I'll show you the special topics page and what you can get at from there. So from just maps and images, I think that's what it said, I'm just going to do some screenshots of what you can see. Now, these pages are going to be most useful for those that are simply trying to monitor what's been happening. So we really don't do a lot of forecasting, but if you're curious about, well, how much did fall? How much rain did fall over the last week, over the last month, maybe just over the last 2 days, I would say these are pages that you want to go to. This first screenshot is highlighting the daily station maps. And so again, for daily station data, we're just looking at precipitation and temperature. And the 2 rows, one is just the Midwest 9-state area, but because there's so much similarity expanding further west over into the High Plains states, we offer a lot of products extending there as well. If you were to click on any of those thumbnails, then it would pop up a much bigger graphic, because obviously those thumbnails aren't really readable to anybody. They're just to give you an idea of, so what are you about to look at if you click on it. But here's an example of daily precipitation maps that you would get. And then up at the top, you see those hyperlinked. It's like the first row above the map, it's blue hyperlinked. If one were to mouse over those, I can't on this because it's just a slide at the moment, but just mousing over will show what precipitation fell 2 days ago, 4 days ago, and so on, 7 days ago. So you can quickly mouse over and then look at your area of interest to get a feel for how long has it been since I've gotten adequate amount of rain. Is this something I do need to be concerned about? Should my underflow soils be responding in a certain way to the amount of precipitation that I've gotten? Then there's a suite of products that are based more on hourly data. So as I mentioned early on in the talk, with hourly data, we can get stuff such as wind speed, humidity, and so with that we can derive products such as the dew point temperature, wind chill, and heat index. And here's just an example product. This one is for wind chill, what the minimum wind chill was over the last couple of days, which may or may not be important to you for whatever you're doing for agriculture. It could be significant for livestock, but maybe the heat index would be more important if you are concerned about heat health and perhaps crop health. But again, one can mouse over the different days at the top to see how cold was it in terms of that apparent temperature as opposed to the raw temperature. And then finally, this is just a screenshot where you can see the last 7 days, the last 30 days, and then even month to date of a lot of those different products, including snowfall. And I think the example I show here, yes, it's called multi-sensor precipitation. And you can see how much greater detail we offer with this, because this is a combination of both station observation data and what the radar data was providing. So I'm sure many of you look at radar images on your phone apps to see where the storm is, if it's heading towards you. Well, that radar data can provide much greater spatial detail to provide a better indication of, so how much really fell in case there wasn't a weather station right at my location. Moving over to the special topics within that Midwest Climate Watch, you see the variety of topics that we have offered. Agriculture is near the top. Drought obviously is going to be important for agriculture. We have Great Lakes in there, temperature inversions. So that's become a bigger topic, I guess, with chemical applications, and then topics related to winter. I just want to focus on the agricultural page now because of time. And this is a screenshot of a variety of different value-added tools, if you will, that the MRCC has developed based on those observational data that's related to ag resources. And I'll go through several of these, but up at the top, you see there's the useful to usable suite of tools. I'll show you 2 of those. In the top right, we have soil temperature maps. So I'll show you an example of that. And that is borrowing from different Mesonets, or those state-run networks of weather stations. Corn stress degree days, going down below that, just modified growing degree days. Chilling hours, particularly if you are in specialty crop production, freeze maps, etc. So this is really a great page, I think, to bookmark if you just want to go to the tools. Maybe you're less interested in the monitoring. So these are just examples of the modified growing degree day products. That was one of the options on the previous slide. We currently are offering 2 products, one that starts accumulating April 1st of the year, and then the other one, it starts accumulating May 1st. We do have it on our wish list to redesign this tool so the user can just put in their own start date. And then that way that offers some user flexibility. Perhaps you don't really want to be fixed at either April or May, but you want to be fixed at when you planted your crop. So that feature should be coming soon. This just shows, I pulled it recently to show what the total accumulation was, at least through November 30th of last year. And then, of course, climatologists are always curious about, well, how does that compare to normal? So we also provide what the departure is. And these products are updated every day. So throughout the growing season, you can see what the actual accumulation is, and then is that above or behind normal. Moving over to 2 examples I want to show from our useful to usable suite of products. This one is called the Ag Climate Viewer. I have that circled up at the top to see so that you know where to look when you get to the UTU page. Users, when they click on the Ag Climate Viewer, could get a map, and you see all the stations that this product is based on, and it's the stations that I was showing you at the beginning of the presentation. So a user can click on that station, and they are given a variety of options and maps that they can look at. This is just one of the maps where they could see, I clicked on apparently a station in Tippecanoe County, and they can see over time what was the corn yield at that location, and then what is the trend in the corn yield. Here's another product from that same viewer, and you can see the pale blue bar at the top, a variety of different products that you can look at, such as that yield trend, the one I just showed, climate averages, etc. This particular product that I've highlighted does a comparison. So you can compare, if you see in let's see, you can look at the different time periods, you can pick the crop of interest, you can select which parameters to show on the map, and just different varieties here. So with that, you can see, well, how did the yield correlate, if you will, to different weather parameters at that location. And with all of these products, you can certainly see the time series over time, but if you notice in the top right, there is that download data option. So if you want to actually download it and look at this further, you can certainly do that. And then right above the time series, there's something called chart option in the top right above the graph. And if you click on those three horizontal lines, I believe you can then download that time series yourself. If you want to print it out, or if you're going to be giving a presentation somewhere, then you have that option. Moving over to the corn GDD, or growing degree day tool, and I have that highlighted up at the top left. Here, a user can click anywhere within the domain where we have the county outlines, and this product is based on gridded data, so you don't have to be limited to a station closest to you. All the station data has been interpolated to a grid, so the user can click on that grid location and then will be taken to a page where they can put in a variety of parameters. In this case, the user can select what their growing degree day start, accumulation start date is in the top left. If you want to see, well, what happened in some past years to get a feel for how the current year is going, and you can use this tool throughout the growing season, so you can track how the progression is going at your location. You can put in things such as your corn maturity days, silking growing degree days, freezing temperature. So on the chart shown below, if you look to the far right down where it has October and November, those blue lines, and even over in April and May, the vertical almost cyan colored lines show how often there is a freeze on that date based on the temperature that you selected and so forth. So it's a nice curve that you can play with throughout the season to even see, well, what if I planted on this date? Will I get all the way to black layer? Will I get to the point of harvest before hitting what historically has been dates of freezes or hard freezes? There's a whole suite of tools on the MRCC website that looks at frost freeze climatologies. So similar to the last product I showed you, where you can see historically at your location when different freezes occurred, there's a suite of options here that you can look at, such as the middle bar, that the middle column of options shows what the climatologies were, such as the date of the earliest hard freeze. We also have these for 32-degree freezes. What is the median date or the latest date ever? We have a suite of the column on the right of different growing degree days. So what is the growing degree day on different base temperatures? And then also based on when we hit a certain threshold. And then the column on the left shows a bunch of different products that users can click on to see just the current season. So how many days has it been since a particular freeze? How cold did it get? That these last two in the list on the far left, lowest minimum temperature, either 10 to 50 degrees Fahrenheit or minus 38. That was driven by growers, particularly specialty crop, because they knew that temperatures, say, got really cold, and was it cold enough to actually cause damage down into the fruit layer or to the root layer. So this is just one example of an output. So date of the most recent 32-degree freeze. This was taken a year or two ago, just to again show an example. Users can click to zoom in on areas or zoom back, zoom out. And you can see from this different dates, and users can go to this to almost assess their own risk of, well, if it's been this long, do we think it's been long enough for us to feel comfortable planting, or do we think it hasn't really been long enough? Historically, what is that date? And so when you're trying to hedge your bets in terms of planting or assessing the progression of your particular crop, these can be useful products. Chilling hours. So this is a tool that looks at accumulated chilling hours throughout the dormant season. This is particularly useful for specialty crops, perennial specialty crops that might need so many hours during the dormant season to indicate the healthiness or the yield of the upcoming season. So we track chilling hours. Currently, the product is fixed with the boundary temperatures of 35 to 45 degrees Fahrenheit. You can see that noted in the top left of this map. We are currently developing a product, though, where the user can select their own boundary temperatures, because really each fruit variety might have a different range that they need. So anyhow, users can look at this throughout the season, get a feel for how many chilling hours within the boundary has accumulated, because usually those varieties also indicate, hey, anything between 1,000 and 1,200 is wonderful for yield. Anything that's, say, under 700 may not be that good. So you really have to refer back to the product that you're trying to grow or the crop that you're trying to grow. And then with each of these, it even puts it into perspective of, well, how does this accumulation compare to normal? So again, this could be important if you're exploring different crops, thinking about different crop varieties and whether that will thrive in your local area. So if this year or last year, and we do try to archive these maps, we're right on spot for what you needed, or we're always behind or over, then you can take that into consideration for your risk. On the flip side of chilling hours is stress degree days. This is a very simplified way of looking at corn stress, with the idea that when the air temperatures get above 86 degrees Fahrenheit, the plant itself tends to shut down to try and preserve itself with the heat tolerance. And so we do have this product that monitors it throughout the season. This was obviously early in the season, so we hadn't accumulated too many stress degree hours at this point through the majority of the country. But you can see that as of the end of May last year, there were some stress degree days that were starting to form down in Texas. And then just like chilling hours, we do always provide the climatological perspective of, well, how does this compare to normal? And you can see for last year, this was almost significantly above normal for the Texas area, how much warming they had already received by the end of May. Then we have the Regional Mesonet program. This is a project where we have worked with a bunch of the Mesonets. Again, Mesonet is just a network of weather stations, usually for an isolated state. So each of the states you see here, we have data for more networks than other. For example, Ohio, we didn't have any data for this particular product. Indiana was lacking at the time. Now we do have 2 networks from Indiana in there. You can see this distribution of stations across Illinois. The products that we provide are listed on the left, so you can look at what the 24-hour and then 7-day average is of soil temperature at both the 2-inch and the 4-inch depth at under bare ground and under sod or vegetative coverage. So if you are wanting to wait until soil temperatures at the 4-inch depth get to be 55 degrees Fahrenheit or 50 degrees Fahrenheit, this might be a useful product for you to consult. And it is updated daily. And we also provide potential evapotranspiration data from this as well. We are updating this product this year to try and include many more Mesonets. So we do, like I said, we'll fill in Indiana if it's not already filled in, Iowa, Kansas, Nebraska. I guess it's Nebraska that looks a little thin here. So keep an eye out for that. One of the challenges that we have is some of them have it under sod, but they don't have it under bare ground, or some of them just have 4-inch, but not 2-inch. So when you go from one product to the next, it might look like there's a lot of spatial gaps, but we're trying to explore ways to minimize those spatial gaps and not assume too much between station location. And I think this is my final regional tool. This is a freeze date tool. We just recently launched this, probably within the last 6 months. The idea here is another way of looking at what are the typical dates of particular temperature thresholds when we think about freeze in the fall and the spring. So along the top, you see the gray bars, and you can look at a first fall freeze date map, the last spring freeze date map, and then the total growing season length map that are based on those freeze date parameters. And then you can also look at time series of these for each location shown. And so we do this by county over this domain that you're looking at. And then on the far right, there are options. So the user can select which temperature threshold they're interested in. And then on the select statistic, I believe with this, you can select what is the average date, what is the earliest date, what is the latest date. And so it can be useful again if looking at your own location and your own temperature of interest. So in this case, I clicked on Vermilion County, Illinois, because it was right along our 2-state border. And I'm now looking at a freeze date trend tool, and it looks like this product is for the last spring. So we can think about this coming up. Each column that is represented here is of the different temperature ranges from 20 degrees Fahrenheit to 40. So think of these as almost, 8 different products that we're showing all at once. The vertical axis is the actual date, so running as early as March 1st or even into February, down into the summer. And then you can see along the horizontal axis all the dates that it occurred for that particular temperature range. And I think we start at 1950 through last year or through 2021. So you can use a product like this for the county that you're in. If you say curious about the hard freeze threshold, the 28-degree threshold, you can then look at that general column and get a feel for, has that date, that average date when we hit that last occurrence, has it been changing? And you can see, for regardless of the temperature threshold, with perhaps the exception of the 20-degree, the date has actually been getting earlier and earlier over the last 70 years. For some temperature thresholds, like the 32-degree temperature threshold, that trend has been pretty extreme. That is a strong slope line. But for, say, the 28-degree temperature, that slope line, while the date has been getting earlier, it hasn't been getting earlier as extremely as the 32 has. On the flip side, I show what is that change for the fall date. And so in the top right under summary stats table, you see it says choose freeze date, and I have selected first fall. Again, it's the same layout, but the user can look at this to see, has that date in the fall, when the first occurrence of, say, a hard freeze or whatever temperature you're interested in, has that been changing over time? And also, what is the variabilities? Because a lot of this translates back to risk, particularly if you're trying to think, will you make it through harvest, or will you make it to a certain point when you are doing practices that are dependent upon the temperature? Lost my cursor. Here we go. And then this is an example of a time series of the growing season. So the growing season length, each bar is essentially going from the first date of that, or the last date of the spring freeze based on the temperature the user selected, up until the first occurrence in the fall, so that a user can look at this and see, does the length of my growing season based on the temperature I've chosen, and all of those parameters are off to the right, where the user can select their temperature. They can select what period. Do they just want to look at the last 10 years, the last 70 years, etc. And it will give them an idea of, have our growing seasons been lengthening? In this particular case, if we look at the trend lines, the top trend line has a slope to it, meaning In this case, the spring dates have been getting earlier, but the trend line down in the fall seems relatively level, meaning that we haven't seen too much change in the first fall date based on that 32-degree temperature, but the spring date has gotten earlier. However, look at the variability. How much do you really want to count on that from year to year? So for the last topic, I'm going to switch over to what's offered through the state climate offices. This is a map showing which states have a state climate office. And the reality is all of them do, with the exception of Massachusetts. That one is white. In fact, we even have a state climate office in Puerto Rico and Guam that I think is not shown here, but certainly Puerto Rico. And the shading here just is if that state climate office is acknowledged by the National Association. So both Illinois and Indiana are recognized state climate offices. While the state climate offices do a lot, the thing I wanted to highlight most for this presentation was our two Mesonets. And so again, a Mesonet is a fancy word of saying a Mesonet network, that's where the word Mesonet comes from, of weather stations. The map on the left shows the weather station locations in Illinois and lists the cities. Down at the bottom of that, it shows some of the products or the variables that they collect at those stations. And then the map on the right shows the two networks that Indiana has. We actually have a Purdue network that is the gold circles, if you will. And then Indiana University, out of the Geological and Water Survey, operates the Indiana Water Balance Network. Those are the blue filled in circles. And then there's two gold triangles on the map, one in Vermilion County, and then one far north central that is in Elkhart County. And those are locations that we're hoping to install new stations for the Purdue Mesonet this spring. In the center gold box just lists the different parameters, the variables that we are measuring from the Indiana network. And really, if you compare both the Illinois and the Indiana Mesonets, we pretty much are observing the same thing, archiving the same data, et cetera. In fact, a lot of the Mesonets in the Midwest, we talk on a monthly basis. So there's a lot of collaboration, cooperation that goes on to make sure that we try to have similar, at least sensors across our network. We still have a ways to go to offer similar products. For the Purdue Mesonet Hub, and I just use this as an example to show you some of the products you can get when you go to these Mesonet sites. Highlighted down in the bottom center, you can see that we collect data at 30-minute intervals, and so you can also get hourly and daily summarized parameters. The screenshot on the left shows our stations, so a user can just simply click on any of those green dots, and that will take them to a data spreadsheet page, like is what's shown on the right. And from here, a user can select what time frame they're interested in. They can even just restrict it to certain months. So if you're curious about what precipitation amounts there were for that location just during June and July, you can certainly do that. That way you're not having all 12 months muddy up your data. And then you can download that data freely. Additionally, there are time series, just like I've been showing a whole bunch of all those parameters. In this case, I'm showing two different time series products. The one on the top is low-level inversions. So again, thinking about chemical applications and wanting to minimize, if not completely avoid, off-target drift situations. This is a product that shows if there is an inversion present. The vertical brown bars are indicating that there is an inversion at this particular location and how strong that inversion is. And you can see that it has a periodic pattern to it because these inversions tend to be strongest overnight and into the morning hours, and then goes away in the early afternoon. So that's why we kind of see them get really large and then decrease and large, decrease. The red lines, and if you look over where the brown bars are greatest, you can start to see the orange and the yellow as well in here. Those are just the temperature curves. And then the time series below that, we have soil water sensors at all of our sites. And you can see from the legend the depths that these sensors are at. So 2-inch, 4, 8, and 20-inch depths. And so this provides us an indication of how wet the soil is. And in Illinois also has soil water sensors. I don't know if it's those 4 same depths, but they would be close to it. So in just showing some more about the Illinois Climate Network, you already saw the map on the left, but I also took a screenshot of some of the other products that they provide on the right. And so they do have things such as a pest degree day calculator, growing degree day calculator. They might have several other model products that are relative to agricultural production, which would be very useful, I think, for many people. Indiana, we are still trying to develop those products. So if you are looking at either the Purdue Mesonet or the Indiana Water Balance Network, we don't have those models developed yet for our Mesonets, but it is on our wish list, and we certainly hope to have them developed probably within the next 3 years for sure, if not sooner. So that wraps up everything I was going to say. I'm just leaving it at this site where I provide you with my email if you have any more questions. And then the general URL, so we have the mrcc.purdue.edu will get you to the Midwestern Regional Climate Center's page. And then the second URL can get you to our Indiana State Climate page, which will provide you data to the Mesonet. But obviously that second URL is somewhat complicated. So if you just Google Indiana State Climate Office, it'll probably be easier. So with that, I'll hand it back to Hans.
Okay, thank you, Beth. I don't see any questions that were entered in the chat, but I encourage everybody, if you do have a question, go ahead and enter it. I'll cede one question to Beth. You talked a lot about the tools and resources that exist at the moment. Is there anything coming down the pike that you believe everybody should know about, or anything that excites you that may be yet to be developed?
Yeah, so I mentioned that we are going to be converting several of our tools so that there's a lot more user flexibility, such as the chilling hour accumulation tool. We'll be modifying so that you can put in your boundary temperatures. Growing degree day products, the user can put in some more of their parameters. But a tool that I didn't mention that we're in the very early stages of developing is a soil temperature climatology tool. And we've been trying to explore how to do this, because one of the later slides I showed was how we're grabbing soil temperatures from the different mesonets. But you saw that there were spatial gaps throughout the area. So we're exploring using a gridded data set, so there are no spatial gaps. And the user can click anywhere where their field is, and then that will provide them an indication of what is the average date when the soil temperature, we're going to say 4-inch soil temperature, but I think we can have the option to add different depths, have a certain temperature. And so not only is it going to be exciting to have that climatology tool available, but the users will be able to select, well, what temperature are they most concerned about? Is it 50 degrees? Is it 55 degrees? Is this more for the timing in the spring or the fall? And similar to some of the other tools I showed, they could say, well, what's the average date? What's the earliest it's ever occurred? What is, the 10th percentile, 25th percentile? So we hope to offer a lot of user flexibility with that soil temperature climatology tool, like we do with the other ones that we're working on. We hope to have a beta version maybe by this fall, and then we can formally launch a final product by next spring. So I don't think we'll have anything really for public viewing this spring, but hopefully by the fall, we'll have something.
Okay, thank you very much. I do want to mention that I've started a poll. Please do fill that out as you're able or have time. I'll leave that up for about another minute. We do have a smaller group today, and Helen has her hand up, so I will allow participants to unmute at this time. And I'll ask Helen, go ahead and unmute yourself and ask your question if you'd like.
Okay, thanks, Hans. Sorry, I forgot about the unmuting thing. Beth, thanks so much for walking us through all of those tools and data. That was a great overview of all those resources. My question is, if I'm a farmer and I am interested in understanding, that data and trying to figure out, I guess my question is there someone I can talk to, or is there an office I can go into with someone who will walk me through how all that data translates into what decisions I should be making on the farm?
Yeah, I would say depending upon where that tool came from. So if it came from the Midwestern Regional Climate Center, then there's usually a product description link to all of those. I think we're still working on building those up. So that might provide some further information of how would you use this tool? What does it mean? If you still have questions, then the website has contact information. I think it's generic, like mrcc@purdue.edu. And you could say, hey, I was looking at this tool and I was just kind of curious how to apply it this way. We have multiple people that read that inbox and so can respond. And if you are on campus or near campus, you can certainly stop in either the state climate offices. So Trent Ford in Illinois would be able to help you interpret any of these products just as well as I would, or anyone at the MRCC. So those would probably be the best routes, I would say.
Great. And yeah, I guess just a follow-up on that. Is there any movement to try to kind of do like broader training for folks in conservation districts or something who are, talking with farmers, about making decisions on the farm and, having them equipped with some of these tools as well?
Yeah, I think Trent and I are both always willing to give presentations. So we just don't know where the need is. So if you know of folks, it's like, hey, I think this would be great if we could have them give a similar talk or talk to us. Then I would encourage reaching out, and then we can do that. If you think there's even a broad regional need, sometimes those conservation districts are part of a regional group, and then we can do webinars like this that can help reach a broader audience.
Great, thanks.
So I did want to follow up on that and state that Dwayne and I's purpose for beginning this webinar series is pretty much exactly what you were talking about, Helen. We wanted to do a webinar series before we gauged interest in maybe doing kind of a bi-state on the ground in person setting, but we would have to have dollars to do that. So if you're interested in Dwayne and I putting something together for an in-person meeting, by all means reach out to us. We'd love to help with that.